Hi guys, in this video we are going to discuss about 2.3, the periodic table. 2.3.1, the historical development of the periodic table. As early chemists worked to purify ores and discovered more elements, they realized that various elements could be grouped together by their similar chemical behaviors. One such grouping includes lithium, sodium, and potassium. These elements all are shiny, conduct heat and electricity well, and have similar chemical properties. A second grouping includes calcium, strontium, and barium, which also are shiny, good conductor of heat and electricity, and have a chemical properties in common. However, the specific properties of these two groupings are notably different from each other. For example, in the lithium, sodium, and the potassium are much more reactive than are calcium, strontium, and barium. Lithium, sodium, and potassium form compounds with oxygen in a ratio of 2 of their atoms to 1 oxygen atom, whereas calcium, strontium, and barium form compounds with 1 of their atoms to 1 oxygen atom. Fluorine, chlorine, bromine, and iodine also exhibit similar properties to each other, but these properties are drastically different from those of any of the elements above. Dmitry Mendeleev in Russia and Lothar Meyer in Germany independently recognized that there was a periodic relationship among the properties of the elements known at that time. Both published tables with the elements arranged according to increasing atomic mass, but Mendeleev went one step further than Meyer. He used his table to predict the existence of elements that would have the properties of similar to aluminum and silicon but were yet unknown. The discoveries of gallium 1875 and germanium 1886 provided great support for Mendeleev's work. Although Mendeleev and Meyer had a long dispute over priority, Mendeleev contributes to the development of the periodic table are now more widely recognized in figure 2.10. You check out the figures on the below, which is known as the periodic table, which is given with the Dmitry Mendeleev and Lothar Meyer. So in the Dmitry Mendeleev, by the 20th century, it became apparent that the periodic relationship involved atomic numbers rather than atomic masses. The modern statement of this relationship, the periodic law, is as follows. The properties of the elements are periodic functions of their atomic numbers. A modern periodic table arranges the elements in increasing order of their atomic numbers and group atoms with similar properties in the same vertical column. Each box represents an element and contains its atomic number, symbol, average atomic mass, and sometimes name. The elements are arranged in 7 horizontal rows called periods or series, and 18 vertical columns called groups. Groups are labeled at the top of each column in the United States. The labels traditionally were numerals with capital letters. However, EUPAC recommends that the numbers 1 through 18 be used, and these labels are more common for the table to fit on a single page. Parts of 2 of the rows, a total of 14 columns, are usually written below the main body of the table. The periodic table of elements is shown. The 18 columns are labeled group and the 7 rows are labeled period. Below the table to the right is a box labeled color code with different colors for metals, metalloids, and non-metals, as well as solids, liquids, or gases. To the left of this box is an enlarged picture of the upper leftmost box on the table. The number 1 is in its uppercase. Upper left hand corner is labeled atomic number. The letter H is in the middle in red, indicating that it's in the gas. It's labeled symbol. Below that, it's the number 1.008, which is labeled atomic mass. Below, that's the word hydrogen, which is labeled name. The color of the box indicates that it's a non-metal. Each element will be described in this order: atomic number, name, symbol, whether it's a metal, metalloid, or non-metal, whether it's a solid, liquid, or gas, and atomic mass. We will show you this on chemistry reference computer science, as we have determined before. And this is important to you to understand what the major consequence is. Thanks for listening.